This is my code for LAB06, driving the Romi Robot 120 centimeters, making periodic stops along the way. We'll be using our encoders and our ultrasonic sensor. Here are our static variables, the ones we have defined. We've seen wheelbase, wheel diameter, counts per revolution, that's all the same. Distance 1, we'll be subtracting that from the 120 to make our first stop. Difference, max speed, min speed, these are all things to keep the motor within a certain range. I don't want it going over 255 or max speed. Button delay of 2 seconds. Serial delay, once again, my code behaved a certain way with serial prints. When I took them out, it behaved differently. Turned out it needed those delays for whatever reasons, at least from my experience, so I've gone back and put a delay of 10 seconds. We have our trigger, echo, inches, these are all given to us in the Romi basic sketch. My speed, I'll be traveling at 40 pulses per motor. Ultrasonic, that's a variable I use to store the ultrasonic measurements. Array size of 5 is what I'm using. I've named my float as an array. My float name is my array. A median, we'll try to take the medium, and INT pass is a way that I can determine where I'm at in the loop, and I'll go over that in a second. Let's see, we have our setup, and this is the loop here. The first one, we have a function that's green LED. First we wait for the button to be pressed. Once it's pressed, we go into our loop, and the green LED function will be initiated. The green LED function, the LED light for the red is turned off. The green is turned on. We have a 2-second delay for the button. Then the green goes off. We then go into our first drive straight function, and we're using that distance 40, which will it will stop at the 80 centimeter mark on our track, and we'll see that in a second. We will then go to and we'll go real quick to the drive straight. It's a function of speeds and distance. Ultrasonic here, and then the other ones we'll be getting our distance from the ultrasonic, and we'll see that in a second. As usual, we have the counts left, counts right, number of pulses, pass plus 1. That just helps me determine where I'm at in this loop right here. Count right, counts are left. If the left counts are greater, if the count on the left or the count on the right are less than the pulses, of course we're going to go. We'll adjust our speeds, and then after that's been fulfilled, we will stop our motors. And if the pass equals 5, which it won't until the last, we will turn on the red LED. Okay, so we got our second ultrasonic, our second drive straight function, and we're using the ultrasonic measurement divided by 2, so half the distance it's reading. As we can see down here, this was provided for us in the Romi Robot, the Romi Ultrasonic Basic. We had this. What we did to it, what I did to it is we were provided an array, and I worked to an array that put our ultrasonic sensors in numerical order. So here's that. I used a code, modified a code I found off Code Academy for the bubble sort, and so it does take the median, and I used that. I put it back into the Romi Ultrasonic, and it worked for that. However, when I returned that median value within the void loop, it messed up Romi Robot. It, for whatever reason, did not want to stop. So what should have happened is the distance calc should have equaled the median, and theoretically that's what should be done. For this setup and for the sake of just getting a good run out of the robot, I took that out, and we're just returning the distance calculation as we initially had. We had one other filter, and the Romi Robot, it since it's between 2 centimeters and 4 meters or 400 centimeters. So what I'm doing here is, in this if statement, is kicking out any value that does not fall within that bounds. For example, reading like 0 or reading like 1200, we'll assume that's false and not use that. Anyway, whatever's returned here, and like I said, initially I wanted the distance calculation to equal the median. It will be brought back in to our drive straight function from here, and it will use that to calculate the number of pulses needed to go half the distance it measured. It does that, and it's predicted that I had predicted stops at 80 centimeters, one at 40, one at 20, one at 10, one at 5. Once it hits the one at 5, like I said earlier, pass will equal 5, and it will turn on the red LED. And we will stay stopped with the red LED on until the button is pressed again. So what we'll do, and we have our Romi Robot without the front caster, we'll go ahead and upload this code. And we are done. So we will, well, I don't know if we saw the code being uploaded. Let me do it one more time. We can see on the robot. There we go. Now we're done uploading, so I will undo that. And we'll take a quick look at the course here. So we can see that we have 47.2 inches, approximately 120 centimeters. We also have markers here at 120 centimeters, 80 centimeters, 40, 20, 10, and 5. So I've noticed that code is not working 100% like it should. It seems to want to skip 1 or 2 stops along the way, and that's something to do with the code. I think maybe there's a delay in there that's not correct. Regardless, let's go ahead. Set it here. And I will hit the, well, first let me make sure we can see this. Go ahead and, whoops, start button. Green LED comes on. Yeah, green LED's off. So we're going, makes our first stop at 80. And I predict it will probably skip this one. Or stop right before the 20. Stopped again, and we are, how far away are we from the wall here? So we skipped 2 stops, and it looks like we are actually 6 to 7 centimeters away from the wall. So not the best results, but this is my submission. Again, I will work on this, and hopefully I can have this corrected.